And in today's episode, among other things, you'll see this. The Chinese robot has evolved impressively and already starts the fight with intelligent robots. In addition, we'll also see China's new nuclear battery, which lasts almost 5,000 years. For an increasingly aging population, they've created a sanitation robot that goes to the bedside and cleans itself. The first bionic drone that flies and swims like a seabird does. And a hypercar that defies gravity and drives upside down. Let's break down all that and a few other new tech developments. Opening. Hello, impressed viewers. I'm Carlos Alves, and you're watching Impressive Reality. And yes, it's really cold, and I have a little blanket down here, revealing some behind-the-scenes stuff. Did you miss this here, huh? Let's get to the video. The development of artificial intelligence embedded in humanoid robots is about to leave those peaceful lab tests behind and enter the most brutal environments possible for these bipedal machines. A combat arena. The Chinese manufacturer Unitree announced a new international competition where intelligent androids will be put face-to-face to fight, fall, react, and test the physical limits of robotics in real time. And we're not talking about small remotely controlled robots here, okay? These are humanoid machines capable of performing complex movements and responding to the opponent's behavior. The real challenge was never making a humanoid robot walk in a straight line or carry boxes inside a factory. The real problem starts when unpredictable forces hit the robot's body. During a fight, for example, each blow instantly changes the machine's center of gravity, forcing its systems to recalculate posture, balance, and movement, all in a matter of fractions of a second. And that's exactly why the arena can serve as one of the most extreme stress tests ever created for bipedal robots. To stay upright, humanoid robots combine high torque density actuators with sensors capable of tracking the opponent's movements. Dynamic balance algorithms make continuous adjustments to the legs and feet, while perception systems calculate distance, trajectory, and speed, all to decide when to attack, block, or retreat. Each impact also tests the durability of the joints, the structure, and the electronic components protected inside the chassis. But the most important result may come after these fights. Each fall, miscalculated hit, and successful recovery will generate data that can be used to improve new models of control and movement. In this way, the ring is no longer just a spectacle for the human audience and becomes a high-intensity laboratory capable of revealing flaws that would hardly appear in controlled environments. The new Unitree arena shows that the evolution of humanoid robots will also be built through their own physical limits. By learning to withstand the unpredictable, these machines can become much more agile, robust, and prepared for the real world. Silicon now enters the ring, and each blow can help build the next generation of these intelligent robots. So, does humanity really like violence that much? Before there were gladiators. Today we have MMA and similar things. And now, from here on out, will there be robots fighting against robots, destroying each other? Let me know in the comments, okay? This really helps the channel and also helps YouTube recommend more videos to you. New videos that I'm always posting here, all right? Click and leave a comment to help me out. Now imagine a battery capable of continuing to produce electricity, not for days, months, or even decades, but for thousands of years. A device that could power sensors in inaccessible regions, space equipment, or future medical implants like Neuralink, for example, for periods far longer than a human lifetime. This reminded me of that series, The 100, huh? Remember that chip they used in their heads? Well, Chinese scientists have developed a new generation of miniaturized nuclear battery that is based on carbon-14, a radioactive isotope with a half-life of approximately 5,730 years. It's a fact that nuclear batteries are not a recent invention. For several decades now, similar technologies have provided power for space missions, where replacing or recharging a battery is simply impossible. However, the challenge has always been to reduce these structures and increase their efficiency. To overcome this barrier, Chinese researchers developed an architecture that is compact and abandons traditional heat conversion, directly capturing the energy released by the radioactive material. The secret lies in the silicon carbide transducer. In a way similar to how a solar cell works, the semiconductor receives the particles emitted by carbon-14 and converts part of that energy into direct electric current. The new architecture uses three-dimensional stacking, which reduced the required volume 17-fold, increased the maximum power by 2.6 times, and significantly decreased the amount of radioactive material compared to the previous generation. But there is a fundamental difference between duration and power. The battery prototype produces only 1.13 microwatts, which is not enough energy to, for example, charge a smartphone or power high-consumption equipment. Its real advantage lies in providing small amounts of electricity continuously over extraordinarily long periods. It is precisely these characteristics that open up applications in remote environmental sensors, space devices, and electronic systems that need to operate for decades without any maintenance, such as, for example, a chip in the brain. And in the future, more efficient versions could also expand the use of this technology in ultra-low-power medical equipment. For decades, the industry tried to produce clean hydrogen using huge amounts of electricity, which means the numbers just didn't add up. But a new energy race is starting from a completely different idea. What if, instead of producing this fuel, we could simply extract it from underground? Yes, in Canada, a startup has begun a new phase of drilling in search of so-called natural hydrogen, or white gold as some call it, which is gas formed by geological processes and stored in underground structures. Scientists already knew that this gas exists. The problem has always been finding reservoirs that are able to maintain enough concentration, pressure, and flow to justify a commercial operation. In other words, one that would be profitable for them. That's exactly what Max Power intends to test by using new wells to turn a promising geological discovery into a possible continuous production system. The first target is at the apex of an underground structure mapped by geophysical surveys. Seismic data made it possible to reconstruct an area of structural closure of approximately 14 square kilometers, guiding drilling to a region where gas may have accumulated in higher concentration. Previous tests recorded hydrogen contents of up to 28.6%, as well as the presence of helium, which is a strategic resource used in medicine, the semiconductor industry, and various advanced technologies. If the results confirm the potential, Canada could open a new front in the race for natural hydrogen. Instead of spending huge amounts of energy to manufacture the fuel, humanity could now tap into reservoirs produced by Earth's own geological processes. The so-called white gold still needs to prove it can scale, okay? But the race to find it has definitely already begun. One of the most intimate and delicate tasks in caring for the elderly and people with reduced mobility may be about to be transformed by robotics. Instead of forcing the patient to walk to the bathroom during the night or constantly depending on help from a human caregiver, a Chinese company has developed a robotic toilet that is capable of going directly to the bedside, carrying out the entire hygiene process, and then returning by itself to a station where it cleans itself automatically. The problem this technology tries to solve goes far beyond comfort. Trips to the bathroom do pose a risk of falls for the elderly and patients with limited mobility, and they also require constant physical effort from family members and healthcare professionals. Presented by Yoban at an elderly care fair in Shanghai, the so-called Zio Sioban transforms the traditionally fixed bathroom into a mobile, on-demand structure. To work inside rooms, the system had to solve a very obvious problem: the waste. A layer of foam helps contain odors immediately, while internal activated carbon filters treat the air. After use, the integrated module washes and dries the user, thus reducing the need for human assistance in one of the most sensitive stages of daily care. Then the charging robot uses navigation sensors to automatically return to its station. There, the stored contents are disposed of in the sanitary system, and the reservoir goes through an automated cleaning and disinfection cycle, preparing the machine for the next use. More than just replacing a bathroom, Sioban represents a significant change in the role of domestic robots. In a society that is aging rapidly and facing a shortage of human caregivers, these machines can take on repetitive and physically demanding tasks, all without removing humans from what really matters, which is care, companionship, and attention. And speaking of robots giving humans attention, what if these companion machines of the future abandoned wheels, mechanical legs, and even noisy propellers so they could simply float around our homes like little living creatures? Researchers from Japan and the United States are exploring a new class of soft robots supported by Helium. These are capable of sharing the same space as humans without the dangers normally associated with flying machines. That is, a propeller cutting someone's head off out there. Inspired by characters like Tinker Bell and a certain Pokemon E, these devices can approach, gently touch a person, and even wrap them in a kind of hug. Conventional drones have never been ideal for home environments. Besides the constant noise from the motors, their propellers pose a risk to children, animals, and anyone nearby. To solve this problem, researchers from Keio University, in partnership with MIT, transferred the lift to a helium-filled envelope. Since the gas keeps the robot in the air, small propulsion systems only need to control its direction. The challenge is the weight, you see. 1 liter of helium can support approximately 1 gram, which forces engineers to use very lightweight structures. Microservos, compact batteries, and components will be reinforced with carbon fiber for this reason. Part of the processing can also be done externally, reducing the amount of onboard hardware. But the most interesting concept in all of this is what's called safety through compliance. Instead of relying only on sensors to avoid collisions, the robot's own soft and inflatable body absorbs the impacts, and that's what allows for intentional physical interactions. It can gently touch a person's shoulder to get their attention, and it can also follow users around the house or navigate stairs and obstacles that are inaccessible to wheeled robots. So, what do you think? Would you have a little robot like that rolling or flying around your house? And since we're talking about flying robots, let's continue here with scientists from MIT and now from EPFL, who have developed a small robot capable of flying, diving into water, swimming, and then taking off again using the same set of wings. Weighing about 250 grams, the machine tries to solve one of the toughest challenges in robotics, which is to build a single propulsion system capable of working in 2 completely different environments. The problem lies in physics. Water is about 800 times denser than air. An efficient wing for flying can experience enormous forces when submerged, while a structure designed for swimming is usually too heavy to take off. Instead of creating 2 independent systems, the researchers developed flexible wings capable of passively adapting to these environments. When in the air, they flap at a high frequency to generate lift. Underwater, the resistance of the liquid itself causes the wings to deform, reducing drag and the load on the motors. The robot was also designed with near-neutral buoyancy, so it doesn't have to constantly use energy to rise or sink. But the biggest challenge happens at the boundary between these 2 worlds. To get out of the water, the robot needs to tilt its body at the right angle and perform a quick sequence of flaps that can break the surface tension. And in less than a second, it manages to leave the aquatic environment and return to flight. Built with relatively affordable components and parts made by 3D printing, the project can also pave the way for low-cost drones capable of monitoring rivers, oceans, and coastal regions. By copying solutions that have already been perfected by nature, robotics is starting to create machines that don't have to choose between the sky and the ocean. They'll be able to master all of that, all right? Both worlds. And speaking of different machines, what if an electric car could generate so much force against the ground that, in theory, it would be able to drive upside down on the ceiling of a tunnel? The British company McMurton Automotive is taking this concept to the extreme, with an electric hypercar costing around $1.3 million that is capable of generating about 2 tons of downforce even when it's completely stationary. Instead of relying only on large wings and airspeed, it uses powerful fans to literally suck the car down onto the asphalt. In conventional race cars, downforce increases as the vehicle accelerates, which means that at low speeds, the wings and aerofoils produce relatively little force. The Sperling, as the car is known, solves this problem in a different way. 2 electric fans that spin up to 23,000 revolutions per minute remove air from a sealed area under the chassis, thus creating a low-pressure zone. Movable skirts help seal this space against the ground, turning the bottom of the car into a kind of giant suction cup. The result is such an intense grip force that the vehicle can handle turns and braking close to 3 Gs. It's precisely this ability to generate downforce regardless of speed that fuels the idea that, under the right conditions, the car could produce enough force to support its own weight, even when upside down inside a tunnel. And there's no shortage of power, you know? 2 rear electric motors deliver almost 1,000 horsepower, taking the small single-seater from 0 to 96 km/h in about 1.5 seconds. With only 100 units planned for sale, it will hardly be a common car on the streets. But its technology shows something truly extraordinary. When aerodynamics no longer depends only on the wind, even gravity starts to seem negotiable, doesn't it? If you like this episode, please make sure you're subscribed, and choose one of the 2 suggested videos. Clicking really helps the channel. See you next time. Thanks, I'll wait for you there. Click 1, I'll be waiting for you there.